So we're going to take a look at how to relate moles to something a little bit more relevant, a little bit easier to visualize, which is mass. We've weighed things in this class a bunch of times before. Using a scale is not such a weird thing, and it turns out a lot of compounds, even though there's that gigantic number of particles present in them, you can actually weigh out a mole of them pretty easy. It's not that much physical stuff. So the big thing to take away, at least starting off, is when we say molar mass, it's mass, it's going to be mass measured in grams of 1 mole of any substance. So this could be atoms, it could be molecules, it could be covalent compound, it could be formula units, it could be an ionic compound. If there are that many particles, that's 6.02 times 10 to the 23rd, whatever particle, that mass. So the biggest thing for any of these, we got 6 different compounds labeled here, is we need to know what the formula is. If we don't know exactly what makes up a certain compound, it's going to be kind of hard to figure out how much 1 mole of that compound would weigh. So we'll look at the first couple here, and I'll set you up for the rest. But so magnesium nitrate is an ionic compound. It may have been a little bit of time since you've looked at these, but for any of these ionic compounds, the only one that's not is the carbon tetrabromide. You need to identify the ions that are there. So in this case, magnesium nitrate, positive 2 versus negative 1. These do not match up, and we can do what we've done a bunch of times now is just cross over the charges, turn them into coefficients. So in magnesium nitrate, we have 1 magnesium, and we'll need 2 of the nitrates, so since it's polyatomic, we'll need parentheses. 2 negative 1s cancels out a positive 2. This checks out. So what I'll do for you is, for these other compounds, I will provide you with the ions at least. This may have been a little bit. The lead is +2. Remember, that's because of the Roman numeral there. Carbon tetrabromide, remember the tetra implies 4, so I'll let you figure that one out. Lithium sulfide. And then finally tin 4. IV is 4. Phosphate. So before we get to solving for any molar masses, we do need to have correct formulas. Take some time, figure out your formulas based on the information we have here, and we will then get into how to actually solve for molar mass. All right. So actually solving for this, hopefully you have your correct formulas. We're going to look at now how many of each type of atom is actually present within 1 unit of these formulas. So magnesium nitrate, magnesium is pretty easy. There's no coefficient. You just have Mg. So we can assume for each one of these there's going to be 1 magnesium, and I'm just going to label it there. You'll see what we do with this. As far as the nitrate, it's made of 2 elements, and that 2 on the outside is going to distribute to both elements that are in there. So for every 1 nitrate, we only have 1 nitrogen, but the formula says that there are 2 nitrates present. So 2 times 1 is going to get you 2 nitrogens. And then finally, we have to do the same thing for oxygen. Now, inside the formula, we have 3 oxygens, and outside the parentheses, there's 2 nitrates in total. So 2 times 3 is going to get you 6 oxygens, and I'm just going to make it look like 6 times that, so it doesn't look like number 60. So now that we know how many of each element are actually in here, we need to establish how much they weigh. So this is where you look at the periodic table, you find magnesium. Magnesium's kind of the upper left a little bit, and you see the decimal number of the atomic mass is 24.3. So this is the mass of 1 mole. This up here. 1 mole of just magnesium. But we want the molar mass for our overall compound. Our overall compound is made up of more elements than just magnesium, but that's what that number represents for us. So we can do the same thing for nitrogen. Nitrogen, you find it on the periodic table, is 14.01 grams per 1 mole, but we don't have just 1 mole present for B2. So we have to multiply that 2 times 14.01. And then finally, we'll do the same thing for oxygen. In the case for oxygen, 6 of them. And you look on the table, oxygen's right next to nitrogen. 1 mole of oxygen weighs 16 grams. So again, things are getting maybe a little cramped here, but the idea is pretty easy. We know how much mass each of our different atoms in this overall compound is contributing. If they're all part of the same compound, if we want to know the overall molar mass for this compound, we just have to add them together. So do that right now. We have 24.3 plus whatever the product, 2 times 14.1, so nitrogens, and then plus 6 times 16. So we end up with all of these added together, 148.32 grams. And since this is a molar mass, it'll be per 1 mole. So if you weighed out 148.32 grams of magnesium nitrate, that compound, that would be 1 mole of it, that would be 6.02 times 10 to the 23rd individual units of magnesium nitrate. So this gives you an idea of how tiny molecules, formula units, atoms really are. Well, that's that many particles, and it only comes out to be about 150 grams. We can weigh that on any of the scales in the class. So let's do a simpler one. One below it. If you got the formula, hopefully you did for carbon tetrabromide. We have carbon, no prefix, just 1. Tetra means there's going to be 4 bromines. Don't have to worry about any parentheses or anything here. It's pretty straightforward. We have 1 carbon. You can find carbon on the table. It's 12.01. And then you find bromine, but there are 4 of those, so we just want to be mindful of that. Bromine's a bit heavier. That'll be 4 times 79.9. So a bit larger there. Scroll up in just a sec. But the math checks out pretty easily. 4 times 79.9, and then add 12.01. So we're just taking these 2 quantities, adding them up, and we end up with 331.61 grams per mole. This is for carbon tetrabromide. So a larger number, yes, this compound is a little bit heavier. Each unit is, because the bromines are pretty heavy. But still, 331.61 grams is not a crazy amount. We could weigh that on the scale. So try out the rest of these. We'll see how they go. And that is pretty much it for molar mass.